Hi students, today we're going to talk about acids and bases, and we're first going to talk about with bases. And the properties of acids and bases you've heard before, at least most of them, in middle school or even elementary school. So bases have a bitter taste, they're slippery to the touch, they conduct electricity, they change color in an acid-base indicator. If you were to use litmus paper, which you might have used before, red litmus paper will turn blue, and they produce hydroxide ions in water, and some examples are soap and lye. So when we name and write formulas for bases, these are the same rules from Unit 5, so if you don't remember them, you can go back to Unit 5. So we're just going to jump into examples. And so I'm going to pull up a periodic table as well. So the first one is SROH. These, for the most part, are ionic compounds, and so you just need to find SR, name it, find OH, and name it. So SR is right here. So that is strontium. And then OH is a polyatomic ion, so that's on the back of your periodic table. So we've got hydroxide, which is the OH, so it's strontium hydroxide. NH3 is the only one that isn't going to be ionic for a base that we will give you. There are more, but that's for AP. NH3, that's also on the back of the periodic table, and don't make the mistake because NH3 is different than NH4. So NH3 is ammonia. And the next one we're going to write the formula for. So remember, these are ionic, so that means we have to cross charges over. So find aluminum. Aluminum is right here. Its charge is a +3. So we'll have Al and then write the charge. Then find hydroxide. We already looked at that earlier, but to show you again, hydroxide is that OH, and it has a charge of -1. So then when you write the formula, the charges, or the numbers of the charges, switch places. I'm going to highlight it. Just the number, not the charge. So this one will go to here, and this value will go to here. Now, we don't have to write the number 1, so we're not going to write that. But the 3 we do need to write, and because we're crossing it to a polyatomic ion, it needs to be Al parentheses OH3, because we want 3 hydroxides, not 3 hydrogens. 3 hydroxides. Okay, let's talk about acids. Acids are sour tastes. They also conduct electricity. They change color in an acid-base indicator. They turn the blue litmus paper red. They produce hydrogen ions in water, and some examples would be vinegar and fruit juices. So, naming acids. So if we name binary acids, which is hydrogen and one other element, except for HCN. I'll explain later why that's a binary acid. When we're doing it, the first word has a prefix, and that prefix is always hydro. Always. It's followed by the root of the second element with the suffix IC. Except they think that sulfic and phosphic sound weird, so they make it be sulfuric and phosphoric. And then the second word is acid. So here is your acids. We're talking about this one. It has 2 elements, except for the 3 elements would be over here and have to have an oxygen. So 2 elements. Here's your thing. Hydro, the stem of the element, and then ic, acid. So H2SE. So because of the fact that you have only 2 elements, we know it's going to start with hydro. So we have hydrogen and 1 other element. So now we need to find Se. So Se is right here. It's selenium. So we're going to take the base. We're going to kind of get rid of the ending. So it's going to be, we're going to take this SELEN and get rid of the eum and have it be, and then we're going to end with the IC. And then it ends in acid. So you need to have that. So hydroselenic acid. Now let's talk about HCN. So it has to be, HCN is going to follow the 2-element one because of the fact that the 3 elements need to include the oxygen. So we're going to do it again. So 2 elements this way. So we start with the hydro. And then we need to find where CN is. That one's on the back of the periodic table because it's a polyatomic ion. And CN is right there. That's cyanide. So we're going to keep the SYAN and then get rid of the ending and change that to IC. So hydrocyanic acid. Naming oxyacids. So naming oxyacids, acids that has hydrogen has to include oxygen and then a 3rd element. Oxyacids are a little bit harder because of the fact you need to figure out what oxyanion is present. Because if you have 8, if it ends in 8, it changes to ic. If it ends in ite, it changes to us. So 8 goes to ic, ite goes to us. And then you just change it to, the second word is just acid. Sulfur and phosphorus are exceptions, like in the binary acids. So we've got, so find which one it is, find the polyatomic ion. If it's 8, it would be the stem and ic. If it's ite, it's the stem and us. And the one way to remember this is I ate something icky. So 8 goes to ic. Okay, so let's find, so these are both oxyacids because they have oxygen and they start with a hydrogen. So let's start by finding ClO. So ClO is right here. So we've got ClO there, and it's hypochlorite. Realize hypo is part of the name, and hypo is different than hydro. So the only reason why I'm writing hypo is because it's part of this polyatomic. So it's hypo, and then we have hypochlor. So hypochlor, because it's ite goes to us. So hypochlor us, and then it needs to be acid. Let's try another one. Let's find NO3. So NO3 is right here. It's nitrate. So we're going to have and then instead of 8, it's going to go to ic. So nitric acid. A little bit more. Writing formulas from names, work backwards from the naming rules. Remember to cross charges over for acids, and always start with H. So we're going to start, so sulfurous. So sulfurous must be oxy because there's no hydro. So that means we're going to be looking over here. So it says sulfurous, us, so that means it must have ite. So we are going to look for sulfite. So we know it's, because it's an acid, we know it's going to start with a hydrogen. And now we need to look for sulfite, which is on the back. Sulfite is that is right here. Sulfite is SO3. So H is SO3, and that is a -2. H is a +1. So when you cross your charges over, you'll get H2SO3. For the last one, hydroiodic, because it has hydro, it's going to be binary, which means it's going to contain hydrogen and one other element. And so we have iodic. So that's going to be, got to look at your nonmetals and figure out what that's going to be. That's going to be iodine. And so iodine is a -1. And so they're both 1s, so you don't have to cross over anything. So we just get HI.